Hey everyone, Mischief You Gay here, and for this lesson we will be talking about the perpendicular bisector, and more specifically, how we can construct one on the coordinate plane. Before we get into that process though, we have a little bit of vocabulary that I would like to talk about. So if you need to pause the video for a second so that you can write what's on the screen here at the beginning of your notes, go ahead and do that. I'm going to proceed now though to talk about what I have written here. So a perpendicular bisector is a segment, a ray, or a line that is perpendicular to the segment at its midpoint. So let me explain that a little bit more in depth. So what we have over here on the diagram at the right is a segment AB. And what I want to do is construct its perpendicular bisector. So those two words we're going to actually mean something separately. So starting with the word bisect. The word bisector means to cut something into two equal parts. In order to do that on a segment, we were going to find its midpoint. And so on segment AB, the midpoint is right here called point P. Let me just erase that little there. Okay, so that is my midpoint. A midpoint is going to divide a segment into two equal parts, which is what's denoted by these two dashes that I have here. So segment AB is now divided into two equal parts, AP and PB. Therefore, it has been bisected. The other part of this is that the line that is going through this at that midpoint has to be perpendicular to it. Now, in order to be perpendicular to something, you have to create a 90-degree angle between those two items. So segment AB, which has now been bisected at P, the line that you see drawn here must be perpendicular or must be intersecting it at a 90-degree angle. And we'll talk about what that means on the coordinate plane. So at its core essential, the word perpendicular bisector, if you break down each word, are the two elements that help you construct what it looks like. Now, one of the reasons this is an important construction that we're going to be talking about in this course is the fact that I have what's down here. It says a point is equidistant if it is the same distance from two figures. So equidistant quite literally means equal distance, hence the term equidistant. Now, what I really want to emphasize here is this second sentence. Points on the perpendicular bisector of a segment are always going to be equidistant from the segment endpoints. Now, that's a pretty powerful relationship here because if I go back to this drawing here, and let me just erase some things so I can emphasize this, the perpendicular bisector is this line denoted with C and P, so line CP. This is my perpendicular bisector. If I pick any point on that red line, let's start with C, okay? What that is telling me is that this C is the same distance from B as it is from A. Now, the reason why this is true and how I can prove this to you is going to make a lot more sense in our next unit when we talk about congruent triangles. For right now, what I want you to look at is just visually kind of tell what's happening here. So if I have that point C, you can see that it's the same distance. It kind of does look like when I draw it that CB and AC are the same. If I pick any other point, let's just make a new one down here. We'll call it D. So I put it in a different spot. If I draw a segment to A and a segment to B, those two green segments are going to be equal to each other. And I'll draw one more. We could draw these all day if we wanted to. I'll put one more here, and this one's going to be purple. We'll call it point E. That point E is going to also be equidistant. So this is going to be an important fact when we get to the second half of this lesson, when we actually apply the perpendicular bisector into some real-world scenarios when it comes to constructing and managing locations of things. So what we're going to focus on this video, the remainder at least, is how we can find the equation of that perpendicular bisector. So here's the four-step process. We're going to go through this four-step process on our first example where we walk through it, and then the second one. So let's go ahead and let me switch my page here to a blank one so that we can go through this together. All right, so here's our first problem. And I notice I have the process here to the right just so that I don't have to keep scrolling. So what I want to do is find the perpendicular bisector of segment DE. So we'll start by plotting those points. So we're going to get 5, -1. So that red point right there is segment D. And my second one is -11, and that takes us off just a little bit here, and then up 3. So that's going to put me right here, okay? So when I connect those to each other, That creates my segment. What I want to do is construct a perpendicular bisector. So we're going to, again, break that word down. The term bisector is what we're going to do for step one. We're going to find the midpoint, okay? So to find the midpoint, we're going to use the midpoint formula. So let me remind you what that looks like. And once we have that written down, we're going to go ahead and find the midpoint. So here are my 2 points once again. So we have x1, y1, x2, and y2. So we'll go ahead and set that formula up. So it looks like for my x's, it's 5 and negative 11. So 5 plus negative 11 over 2. And my second one is going to be negative 1 and 3. So we'll go ahead and find these, and I'm just going to draw it here. So that's going to give me, when we plug those in, so 5 plus negative 11 is negative 6, divided by 2 is negative 3. The other is going to be, what's that, 2 divided by 2, or 1. So my midpoint, the middle of that segment, is located at negative 3, comma 1. So let's go ahead and plot that. I'll use a blue marker for that. And there it is, okay? So there is my midpoint. Now, what we want to do is construct a perpendicular line that goes through that blue dot. So in order to do that, let's go ahead and find the slope of segment ED. So the slope formula is going to look like this. Okay? We're going to use the same numbers as we had before. So my y values are 3 and negative 1. So it's 3 minus negative 1. And for my x's, it's going to be negative 11 minus 5. So we're going to get, when we do that, 3 minus negative 1 is 4, because it's really 3 plus 1. And then negative 11 minus 5 is negative 16. These both go into each other 4 times, and so the simplified slope for this is going to be negative 1/4. Now, that is the slope of ED, but I want the slope of this line that I'll be drawing in a minute to be able to go and intersect that blue dot at a 90-degree angle. So what we need to do is remind ourselves what it means to be perpendicular on the coordinate plane. In order for two lines to be perpendicular, they must have what's called opposite reciprocal slopes. So what do I mean by that? If we need to think about what that means, all right? So opposite means opposite sign. Reciprocal means flip the fraction. So if we just need a very quick flash reminder here, right? If I have a slope of 3 over 2, the perpendicular, which is, this is the symbol for perpendicular, is like an upside down T. Kind of looks like a right angle. The perpendicular slope would be opposite sign, which is negative. Flip the fraction 2/3. I'll do 2 more like this. So if I have negative 4 over 3, okay, perpendicular slope for this would be positive, switch the sign, flip the fraction, 3/4. And then for the last one, I'll do negative 3, just regular 3. Since there's no denominator, we'll write that over 1. And to figure out its perpendicular slope, once again, opposite sign, this time it's plus, flip the fraction, that gives me 1/3. So this is a quick review of how you find perpendicular slopes as they're going to be opposite reciprocals. Since the slope in my problem here was negative 1/4, the perpendicular slope is going to be positive 4 over 1, or just 4. Now, the two important numbers we need here to create the equation of our line is a point in which the line goes through, which we now know is negative 3, 1. That's the midpoint. And the second is going to be what the slope is. So I now know the slope of my line is at 4. So the last step we need to do, number 4, is to find the equation of the line. And then we'll graph it to confirm that it looks right. So to find the equation of a line, in slope-intercept form, we're going to write y equals mx plus b. Now the slope we found in step number 3 is going to be the slope I want to use, because that's we want it to be perpendicular. The point that we want to use is that midpoint we found back in step 1. So we're going to put a 1 in for y and a negative 3 in for x. We're going to solve for b, and then we're going to have our equation. So this is negative 12 plus b. Add 12 to both sides, and we're going to get 13 equals b. So the equation of my perpendicular bisector will be y equals 4x plus 13. This is the equation that I now want to go graph on my coordinate plane, and we will confirm if this is a perpendicular bisector. So let's go on over here. Now, of course, I don't have 13 on here, so we have to be a little bit creative. So we want to go up 1, 2, and 3. So we'll plot our y-intercept there. Since our slope is, I believe, was it positive 4? Yes, it was. We're going to go down 4, 1, 2, 3, 4 over 1. Now, if you're not confident connecting that just because you don't know if that's far, aligned correctly, let's just do another down 4 over 1 just to be safe. 1, 2, 1, 2, 3, 4 over 1. And then if you want to even do a third, 1, 2, 3, 4 over 1. Look at that. There it is. And we'll obviously continue to extend it. This black line that I have on the screen here is indeed our perpendicular bisector. And as I will talk about in our second part of our lesson, any point you pick along that black line will be equidistant, the same distance from point E and point D. They will be the same distance away. Again, we'll get to that later. For now, I want to make sure we focus this lesson on being able to create the line in the first place so that we actually can do these calculations down the road. So it is now your time. You have a second problem, which you do not see on here, but it is a second problem involving points 0, -2, and 2, 2. So what I would like you to do on your problem is looking at this is to go ahead and try to find this. Plot the points and see if you can find the perpendicular bisector. We will then go through it together here in a second. So go ahead and pause the video and try that out. Welcome back. Let's go ahead and go through these. So I've already set up some of it just so we can go through a little quicker. So I went ahead and set up my midpoint formula using my x's in the first piece and y's in my second. 0 plus 2 is 2. 2 divided by 2 is 1. -2 plus 2 is 0. 0 divided by 2 is 0. So my midpoint is located at 1, 0. And it looks like, based on my drawing, that's a pretty confident answer that I have here. Next thing I want to do is find the slope of AB. So we're finding the slope of AB first, and then we'll do the perpendicular next. 2 minus -2 is really 2 plus 2. 4. 2 minus 0 is 2. Therefore, it looks like the slope of the segment I have on there is a 2, which you can confirm if you count rise over run. Now, the perpendicular slope, as we remember, is going to be the opposite reciprocal. So 2 over 1 is going to convert and become the opposite sign negative, flip the fraction 1/2. So the slope that I'm looking for here is -1 over 2. And so for our final step, we're going to take the point that we found in step 1, the midpoint, step 2, the slope that we found, and we will now go find the equation of the lines. 0 equals -1/2 times 1 plus b. And when I do that, we're going to get -1/2 plus b. We're going to add a half to both sides. And so we're going to get 1 over 2 equals b. So the equation of the line that I will be graphing here in a second is going to be y equals -1/2 x plus 1/2. Okay? And so if we wanted to draw this picture so that we can confirm that this looks right, let's go ahead to our y-intercept, which is 0.5. It's purple for this. Okay? Now, going down 1 over 2, I got to be careful here, because going down 1 would actually take me here to -1/2, and then go over 2, 1, 2. There's my second point. If we connect them, you can see that we are creating that perpendicular bisector. So this purple line is going to cut through segment AB at its midpoint, and it is perpendicular. Therefore, any point on that purple line I've drawn is equidistant from both points A and B. And that is all there is to it, this 4-step process. So based on this first part of the lesson, I want you to focus on the 4-step process of creating the equation of the line. Once we have that created, of course, then we'll be able to do some more interesting things with it in the coming lesson. Thank you very much. Hope this video was helpful.